everybody, and welcome to section 10.6. We're going to be talking about secants, tangents, and angle measures. A line that intersects a circle in exactly 2 points is called a secant. So here in this picture of this circle we have two secants, secant AB and secant CD. Notice they are intersecting the circle in 2 places. Theorem 10.12 says if two secants intersect the interior of a circle, then the measure of the angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Okay, so here we have secants AB and CD, and if we just focus on the measure of angle 1 right here, it is 1/2 of the measure of arc AC and arc BD. Also, if we focus on angle 2, its measure would be 1/2 of AD added to BC. Theorem 10.13, if a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. Okay, so let's see what we're talking about here. So here we have a secant and a tangent. Secant is CB, tangent is ABD or just AD, and the point of tangency is right here at point B. So the measure of angle ABC, here's ABC right here, would be 1/2 of the measure of arc BC. So here's arc BC, and ABC, that angle formed, would be 1/2. Alright, how about DBC? DBC is 1/2 the measure of BEC. Now we're not showing point E, but we're talking about this arc right here, along here. So DBC is 1/2 the measure of arc BEC. Okay, Theorem 10.14, if two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle, then the measure of the angle formed is 1/2 the positive difference of the measures of the intercepted arcs. Okay, so let's look and see how this is. Here's the situation where there's two secants. We have secant AD, secant AE, and they are both intercepting the same circle. This measure of angle A right here that's outside the circle, it is 1/2 the measure of arc DE minus BC. Notice DE is the bigger arc, and if you subtract that by BC, 1/2 of whatever's left is the measure of angle A. Now let's look at a scenario where we have a secant and a tangent. Here we have tangent AC and secant AD. Measure of angle A would again be 1/2 the measure of arc DC, it's the bigger arc, minus BC, which is a smaller arc. Now here's the last scenario, two tangents. Okay, we have, let's move that down so we can see it a little better. Okay, we have tangent AB and tangent AC. They're both on this circle here. And the measure of angle A, again, would be 1/2 the measure of BDC, that's this bigger arc, minus the little arc BC. And there we are.